Okay, hi everybody. So in this video here, we're going to look at function notation and some of the operations that we can apply to functions. And then a lot of this is getting used to the notation. What we find is when we introduce function notation to students kind of early on, um, everybody seems to really get it until you then start to ask specific questions. And then all of a sudden, it's not quite so clear. So here, let's take a look at this one here. So f of x is equal to x squared minus 2, and g of x is 1 over the square root of x. I want to find this, and this is kind of an interesting expression here. This, what looks like FOG of x. Now, it's not an O. What that is that's an open kind of a dot, an open circle. Um, a closed circle, if it was filled in, if I was to do this, most of us would immediately interpret that as, oh, yeah, that's multiplication. But it's not. It's an open dot here. And what we mean by that is its composition. This is the composition of functions. And so what this means, and this is an operation that's kind of nicely suited to function notation, kind of pops out of our function notation quite naturally. This means I want to evaluate f at g. So when I look at that expression, I've actually got two sets of parentheses here. One is nested inside the other. Well, I always start with the innermost one when I'm evaluating, and I want to make sure I say that clearly when I'm evaluating. So I start here. G, the function g, takes that x and converts it into a y coordinate. F looks at that, sees an x coordinate, sees an independent variable, and then converts that into its own y coordinate. Okay, so x here is really the independent variable. G changes it into its dependent variable. F, which then becomes the independent variable of f, and then f changes that into the dependent variable. I know it sounds kind of complicated. It is actually fairly simple to work with. What I mean by this is I'm going to start on the inside out here. I'm going to replace g of x with its function. Okay, so g of x becomes 1 over the square root of x. Now, that is in the place of the independent variable in the function notation. So I want you to think of it like this. We know that f of x is x squared minus 2. So I know that if I put, let's say, 3 in here, okay, that means 3 squared minus 2. It means whatever's inside here, I square it and then subtract 2. If I was to put, let's say, a in there, I would take a, then square it, and then I would subtract 2. F is telling me to take what's inside, square it, and then subtract 2. So if I see f of 1 over x squared, I'm going to square that and then subtract 2. And so this is going to be 1 over x when I square that, and I'll subtract 2. Now, I could combine these by finding a common denominator. Don't really need to. That wasn't my intention for this question, but I really could, and make that 1 minus 2x over x, and let that be the simplified expression. But really what I want you to understand here is what's going on with this notation and what we mean when we say f composed with g.